Hello Junior Techies, my name is Natasha Barton, and in today's video we will be taking a look at chemical bonds. We will see how these chemical bonds form, and we will also take a look at those graphs of potential energy versus the distance between the nuclei of two atoms. Let's hop right into it. So, when you have two atoms, or if we just look at one atom, you'll remember that at the center of the atom, we have a nucleus, which is positively charged. Around the nucleus, we have electrons moving in their orbitals. And if you take two atoms and bring them close enough to each other, what you should realize is that they will experience between each other forces of either attraction or repulsion. Between the nuclei of each atom and the electron cloud of the other atom, we find that there is a force of attraction. But since the one atom has a positive nucleus and the other atom has a positive nucleus as well, we find that between the two nuclei is a force of repulsion. And since the electrons in both of our electron clouds of the two atoms are negatively charged, they experience forces of repulsion. Based on this, we can come to the conclusion that a chemical bond will form when there is a net force of attraction between the nuclei and the outer electrons of atoms. Atoms will form bonds when forming a bond results in a lower potential energy when they come together versus the potential energy that they each have when they are apart. Atoms want to be as stable as possible, and when the bond leads to a higher stability, the bond will take place. Now, your teacher may have introduced you to this graph, which is a graph of potential energy versus the distance between atomic nuclei. When our atoms are very far apart, they don't exert much force on each other. But if we move them closer and closer together, we find that they experience a net force of attraction. And this is what is responsible for the graph going down. At some place, or at some point, the potential energy becomes very low. And it is at this point that a bond will form, where we have the lowest and most stable energy state. Now, if we take our two atoms and we move them even closer together, they don't like that, and they experience a net force of repulsion. This is because the nucleus of one atom is repelling the nucleus of the other atom, and the electrons of the one atom is repelling the electrons of the other atom. It is for this reason that we have that the curve goes up, and this is because of that net force of repulsion. Now, your teacher may require you to take some readings off of this graph. Specifically, your teacher may ask you to tell her or him what the bond length of these two bonded atoms is. We say that bond length is the average distance between the nuclei of two bonded atoms. In other words, when this bond forms and we measure the distance between their nuclei, bond length is that distance. The other thing that you will be required to read off of your graph is bond energy. Now, displayed to your screen, we have the definition of bond energy, which reads, bond energy is the amount of energy absorbed to break a specific bond in 1 mole of covalently bonded gas molecules. Now, when you read that, you may be a bit confused because we're using a lot of big words all over the place. I'm going to simplify it for you. What bond energy truly is the energy that the atoms will absorb in order to break the bond that exists between them. Now, in some textbooks, you may see that they define bond energy as the energy that will be released when a bond is formed. You just need to make sure that you please learn the definition that your teacher requires you to learn. So going back to this graph of potential energy versus the distance between atomic nuclei. Remember, at the bottom, at the lowest point on that graph, we have the lowest and most stable energy state. And that is where the bond is going to form. If we go to that point and we read up towards the x-axis, remember on your x-axis you have plotted the distance between the atomic nuclei. So if we go from this lowest and most stable energy state where the bond forms and we read up to the x-axis, this gives us the bond length. And on the graph that is displayed to your screen, the bond length is given in picometers. Now, of course, you'll also have to learn or read off of the graph what bond energy, or how you can read off bond energy. To do so, we again go to this place of stability where the bond forms, and we read or take a reading towards the y-axis, because on the y-axis we have energy, and that value that we get, that is the bond energy. Now, what is important is that we define bond energy as the energy absorbed. So therefore, when you give your answers, you will need to give it as a positive value measured in kilojoules per mole. Ladies and gentlemen, we have reached the end of this video. Thank you so much for watching. I hope to see you watch the next video, which will be about Lewis diagrams and how to draw those. Have a great day. All the best with any exams or tests that you will be writing in the week ahead.